Section 3.5, sum to infinity. Before infinity, we know that the partial sum of n we can write as 1 minus r n o 1 minus r or a r into the power minus r minus 1. Now this is sum up to nth term. Now here we are going to discuss about sum up to infinity. We can find sum up to infinity. It is depend on basically r value. If r is in between minus 1 and 1, we can simply write mod r less than 1, the same thing. Then we can find uh, sum up to infinity as this series is convergent. And if r is minus 1, um, r value less than or equal to minus 1 or greater than or equal to 1, in other way we can write mod r greater than 1, then we cannot find sum sum up to infinity is infinity. The reason is as the series is convergent, divergent. So we can find the sum if the r value is in between, r value is mean common ratio is in between minus 1 and 1. If it is less than no more than minus 1 and 1, then we can't find sum up to infinity because the series is divergent. Example 2 plus 4 plus 6 plus 8 plus dot dot, actually 2 plus 8 plus 16. Find the sum up to infinity. So r value is 4 divided by 2 equal to mod r equal to uh, greater than 1. So what will happen if it is greater than 1? Then we cannot find sum up to infinity. Find the sum up to infinity. Unfortunately, we can't. So we cannot find sum up to infinity as the series is divergent, which I'm going to discuss later. And let's consider this one. 1 plus half plus 1 over 4 plus dot dot. Find the sum up to infinity. So r is half a divide by 1, that is half. So mod r is half less than 1. Hence we can find the sum up to infinity as the series is convergent. Now we will find what is convergent and divergent. Uh, a series is divergent if there is a limiting point when n goes to infinity. We write simply that like this: the partial sum when n is limiting to infinity, the partial sum is or what will happen to the partial sum when n value is uh, goes to infinity. Actually, this is simply we can write this is s infinity. S infinity means limit the Sn when the limit goes to n goes to infinity. What will happen to the limit of Sn? N goes to infinity. What will happen to the limit of Sn? If there is a limiting, what if mean what? If Sn uh, has a limit, has a limiting point when n goes to infinity, and it can't be basically a infinity. Let me do a small correction. If Sn has a limiting point when n goes to infinity, so then the series is convergent, not the divergent. I will explain that. And the divergent mean if Sn does not have does not uh, limiting point when n goes to infinity. So you have no idea what is the limiting point, so which I am going to discuss. Um, if I limit n goes to infinity, the limit of Sn uh, has a value. So in here um, has has no value, has no value. So it's simply, so convergent mean no limiting point. We have a limiting point. Uh, Divergent mean no limiting point. So that's all the summary basically. Let's consider divergent. So case one, um, when r greater than 1. Example 2 plus 4 plus 8 plus dot dot. When you look at r is 4 divided by 2 equal 2. Now when you look at s1 is 2, s2 is 2 plus 4 8, and s3 is 2 plus 4 plus 8, that is 14. Likewise s200 and s200,000. So this is the graph. This is n, the term numbers 1, 2, 3, 4, 5, 6, and this is Sn. So this is uh, when S1, the value is 2. This is S1. So this is the point. So when n value is 2, S2 is 8. Somewhere here. When n value is 3, that is going to be 14. Now you can see, can you think about 200? It's very far, and 200,000 it is going to, so you will get a curve like this. When n goes to infinity, you can see Sn value also goes to infinity. So there is no limiting value. So infinity is not a limiting value. You can see that this is going to infinity. So this is the divergent idea. You can't find a limiting value. So it goes to infinity. Infinity is a limiting value. We don't consider infinity as a limiting value. So what will happen if you see a series and the r is greater than 1 like this? So it goes to the infinity, maybe negative as well. Let's discuss case 2. When r equal 1. Example 3, 3, 3, 3 plus 3 plus 3 plus 3 plus dot dot. So r equal 3 divided by 3 equal 1. So this is a geometric series, and S1 is 3, S2 is 3, 3 plus 3 that is 6, S3 is 3 plus 3 plus 3 that is 9. So basically if this is n, if this is 3, 3 times 3. So this is 1 times 3, 2 times 3, 3 times 3. Basically this is a easy way of finding when r equal 1. So S, I can write 100 is 100 times 3. That is 300. So likewise S n, I can simply write n times 3. Basically 3n. And yeah, S 200,000. So basically 200,000 times 3. So what I want to emphasize that when in an Sn, you can see this is n equal 1, 3, and then 2, 6, right? So basically this is going, when n is increasing, the Sn also increasing. Basically the graph is going towards the infinity. The limiting value is infinity. So we don't consider infinity as a limiting value. So in that case, when r equal 1, still the uh, series is um, divergent because there is no limiting value. The graph goes to the infinity. Case 3, when n r value is negative 1. Example 1 plus minus 1 plus 1 plus minus 1 plus 0, 0. S1 is 1. S2 is 1 plus minus 1, that is 1 minus 1 is 0. S3 is 1 plus minus 1 plus 1. So this is 0 plus 1, again 1. Then S4 is 1 plus minus 1 plus 1 uh, plus minus 1. Again 0. Now you can see that this graph, what will happen, n 1, 2, 3, 1, 2, 3, 4. And when S1 n equal 1, the value is 1. N equal 2, the value is 0. N equal 3, value is 1. And n equal 4, value is 0. Basically, it has two values, 0 and, but it doesn't have a permanent value, because if it is odd number 1, the even is 0. So because of that, this graph is when n goes to infinity, Sn bouncing in between 0 and 1, and because of that, no, since there is no definite value, so the graph doesn't have a limiting value. So since there is no limiting value, if there is no limiting value, the graph is we call divergent. So all the cases the graph is there is no limiting value, and because in both cases the Sn goes to infinity. In this case, Sn bouncing between 0 and 1, and there is no limiting value. Now let's discuss the convergent. Convergent, we have only one case. That case is when R value is minus 1, R 1. So this is the only case we have. And let's consider 1 plus half plus 1 over 8 plus 1 over 16 plus dot dot dot. And S1 is 1, S2 is 1 plus half or 1.5, S3 is 1 plus half plus 1 over, actually this is wrong, 1 over 4, 1 over 8, 1 over 4, this is half plus 1.75, likewise S100 and S2000 or 200,000. So what will happen in this graph, this is N and this is Sn, this is 1 and 2. So N value is 1, 2, 3, 4, 5. N value is 1, the graph is 1. N value is 2, the value is 1.5. So this is the 2 line, Sn equal 2 line. And 3, that is 1.75. And 4 and 5. So basically, if you add like this, this value not exceed 2. So when n goes to infinity, the Sn value limiting to 2. Basically, Sn value, the when n goes to infinity, the limit of Sn value is 2. So we can find this. So by looking at this graph, you can see that it is limiting to a value. It doesn't matter how you limit. Sometimes you may limit to a value something like this, maybe let's say 3, or sometimes you may be limit to a value the negative values, right? It doesn't matter how you limit, but you will see that it is limiting to a value. Actually, this value is 2, which we are going to discuss soon. How we find this. So what is convergent mean? When n goes to infinity, the Sn has a limiting value like 2, then the series is convergent. Or what is convergent? Convergent means it has a limiting value. You have to find the limiting value. in here you the r value is half divided by 1 is half, so it is less than in between minus 1 and 1. Now let's discuss the formula. So we know that Sn equal a 1 minus r over 1 minus r. Now when we consider um, r value in between minus 1 and 1, the series, this one 1 plus 1 over 2 plus 1 over 4, 1 over 8 plus dot dot dot. Now r is half divided by 1 is half. Half to the power, so I'm talking about this r to the power n. R to the power n, it means half to the power n I am going to discuss. Before n, I will discuss half to the power 1. So that is half. Half to the power 2, that is 1 over 4. And half to the power 3, 1 3 over 2 3, that is 1 over 8. Half to the power 1000. So that is 1 over 2 to the power 1000. Now you can see that this value, when n value is increasing, 1, 2, 3,000, likewise, this denominator is increasing. What will happen when denominator is increasing? The whole fraction, value of this whole fraction go towards 0. Now half to the power 200,000. So this is 2 over 200,000. When you divide the number 1 by a very big number, this is going towards the 0. Value is going toward the 0. So basically, if you divide this one by 2 to the power 1 billion, it is almost 0. Basically, when you divide 2 to the power 1 infinity, 2 to the power infinity, it means 1 over infinity equal almost 0. 1 over infinity means 0. So what I want to emphasize here, what will happen to a fraction when the power is increasing? The fraction is, the value of the fraction goes to 0. If it is infinity, then the fraction value is 0. So this is the idea behind it. Not every fraction, not the improper fraction, the proper fractions I'm talking about. Um, yes. So basically, as a result, you will see that when n goes to infinity, okay, let's say r, this is Rn. So when n goes to infinity, Rn goes to 0. So I will apply the limit. I will show you that limit n goes to infinity, the left side Sn, limit n goes to infinity, apply to both sides, 1 minus Rn over 1 minus R. Then I can see that this part is independent from, so I will drag this one out, limit 1 minus Rn. Now you can see uh, what will happen to limit n goes to infinity. So this is 1 is as it is, there's no n. The Rn value, we found out that this value is goes to 0. So hence a1 minus r will we apply limit inside 1 over 0. This value goes to 0. So a times 1 minus r times 1, that is a times 1 minus r. So limit n goes to infinity Sn. So what is the short form of this one? This is we write as infinity, not accurate, but okay. Right. So S infinity is a over 1 minus r. Now we have a formula. Now we'll find the limiting value. So from this formula, so S infinity is a over 1 minus r. R is for the series half. A is 1. So 1 over 1 minus half. So this is going to be 1 over half. So half go up, that is 2. So S infinity is 2 for this series. So this is the limiting value which we discuss. Example 15 in the book. So they have given fourth term is 1.08 and the seventh term is 0.2238. Uh, so we want to find whether this series is convergent or divergent. If it is convergent, find the value up to infinity. Now when you look at this one, convergent or divergent depend on the R. We need to know the R value. We know the standard series A R square like that. So seventh term AR seventh is given 0.23328 and fourth term is given AR3. This is AR6 actually. T7 mean AR6 and fourth term mean AR3, that is 1.08 and this is 1 and 2. So when you divide 1 divided by 2, AR6 over AR3 equal 23328 over 0.1.08. 8 way cancel out, so R to the power 3 equal the answer in the book 0.216, that is R3 is 0.6 to the power 3. So R is 0.6. So R is 6.6. So mod R is 0.6 less than 1. Hence the series is convergent. So series is convergent. So now we know the formula is infinity, okay, is a over 1 minus r. Now we need to find a actually. From 1, from 2 actually, 2 is good. A times 0 point to the power 6, 3 equal 1.08. A equal this value R3 is 1.08 over 0.216, that is A is 5. Now we know A equal 5 and this is 1 minus 0.6, that is 5 over 1 over 6 over 10, that is 5 over 4 over 10, 10 minus 6 over 10, this is 50 over 4, 25 over 2, which is 12.5. So s to the power infinity is 12.5. So when you look at the a value is 5, then 5 times 0.6, that is going to be 30 and 3. So likewise, the s value, s1 is 5, s2 is 3. And so sorry, S2, this is 3. So 5 plus 3, 8. This is 5. Likewise, 1, 2. This is when n equal 1, the value is 5. And 2, that is 8. So likewise, this is 12.5. Graph is limiting to 12.5 when n goes to infinity. In example 16, it is given the partial sum after fourth term is 15 and after infinity 16, and find the possible value for r. From here we need to find r. Then part A. Part B is given r greater than 0. So then find A. So we'll start doing this one. So S4 Sn equal A1 minus Rn over 1 minus R, and S infinity is A over 1 minus R. So when n equal 4, S4 equal A over 1 minus R4 over 1 minus R. So that value equal 15. Then n goes to infinity. S infinity equal A times 1 minus R, that is equal to 16. So this is 1 and this is 2. So we'll simplify this one. Um, I will simplify A1 minus R. Take separately, I will take as A times 1 minus R to the power 4 equal 15. So this is simply A now. A equals 16. 1 and 2. 1 divided by 2. 1 divided by 2. A over 1 minus R4 over A equal 15 over 16. So this is cancel out. 1 minus R to the power 4, 15 over 16. It means R4 to the other side. 1 minus 15 over 16 is R4. So this is going to be 1 over 16 is R4. In other way, R4 is 1 over 16. So R4 is plus or minus half a times 4. So R value, there are two R value. One is half or minus half. Now part B, R is greater than 0. Hence R equal half. So we can drop minus half. Then we need to find A. So we can go to here from 2. A over 1 minus half equal 16. So A over half equals 16. 2A equals 16 divided by 2. A equal 8. You can divide keeping as it is. If I divide 1 divided by 2, A over 1 minus R to the 4 over 1 minus R over 15 divided by A times 1 minus R over 16. So what happened? Minus R4 over 1 minus R times A times 1 minus R equal 15 over 16. So this is cancel out. 1 minus R4 equal 15 over 16. Basically, this is AB divided by CD form. So AB divided by CD, that is AB multiplied by DC. So AD and BC. So AD divided by BC. So this is AD, A times 1 minus R or divided by BC, 1 minus R times A. So then you can simplify. So you got R equal plus or minus